All right, ladies and gentlemen, today in class we worked on compound events with tree diagrams and organized lists. And I think by the end of class, most of you had a better sense of how to work with them. We're going to continue practicing that over the next couple days. But I want to show you another way you can deal with compound events, and that's using tables. So our objective is I can use a table to help me determine the compound probability of two events happening. Especially this is most important when you have a situation where you're rolling two dice. I like to call this the dice chart, and you'll hear me refer to the dice chart frequently, and it is very, very useful for certain situations. One downside, I want you to make a note of this. One downside of using tables is that you can only use a table when you have two events only. So if you have a 3-event or a 4-event situation, like today in class, we did a problem where we had a coin being flipped 4 times, right? And you had to make a tree diagram with 4 different levels. You could not possibly do a table in order to find the solutions to that. And the reason is you'd have to have a 4-dimensional table to do something with 4 levels or 4 different events. When you have 2 events, though, you can make a little 2-dimensional table that can help you. And we can't do 3 events because then it would have to be 3-dimensional, which would get really confusing really fast, and I would never ask you to do that. So let's look, though, in this video on how to do it with 2 events. Prime example is I have 2 die, okay? So when you're setting up this table, you have to think about the number of options you have on each die. So I'm going to have this top part here above my chart. I'm going to have this be the first die that I roll, okay? So when I roll one single die, I can get a 1, a 2, a 3, a 4, a 5, or a 6, right? And then when I have my second die that I'm going to roll, that's going to go down on the other side of the table. 1, 2, 3, 4, 5, 6. Something important to note here, when you have these numbers across the top and down the side, they are not technically part of the chart. They are actually just kind of headings or titles. And the biggest mistake that people make with these dice chart is including these numbers on top and on the side in their final probabilities. And that's just, it's not going to work for you. So let's go ahead and fill out this dice chart, and I'll show you how we do this. Leave plenty of room because we're going to be adding some extra things in here, so don't take up the entire block. In this square here, I would be in this square if I rolled a 1 on the first die and a 1 on the second die. So I'm going to write that in. I'm going to do 1, 1. Make sure you leave about half the square. And then I'm going to have my first die is 2 and my second die is 1. So as you can see, I'm just going to fill out this table, 4, 1, 5, 1, 6, 1. And I'm going to do that all throughout this whole thing. So my first die is a 1 here, my second die is a 2, and then I have 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. I'm going to take some time to fill this in. You guys fill it in as well, please. First die goes first. So what you're probably noticing is that at this point is that this dice chart takes a little while. And I'm sorry. Sometimes the ways you have to do things take a little while. You'll get faster and faster at doing this the more times you do it, though, I promise. Okay, so there's our dice chart right here. And we can use it to answer questions like this. What is the theoretical probability of rolling a die and landing on 4? That's my first event. Then rolling a die and landing on a number greater than 3. okay? So our first thing we need to do is land on 4. So if I go back to my dice chart, I am going to look for any squares that have a 4 first. And I'm actually going to take my pen and scribble out the things that don't have a 4 first. So none of these have a 4 first. They might have a 4 second, but not first. And nothing here has a 4 first. They might have a 4 second, but not first. So I'm going to scribble all that out. Okay? So the only ones that are left are the ones that have a 4 first. Next, I need to see where I can land on a number greater than 3 for my second roll. Second roll is represented by the second number. So where is a number greater than 3? Well, it's right here, 4, 5, 6. So these 3 are out of the running. So how many outcomes do I have where I roll a 4 first and then a number greater than 3? I only have 3 of them right here. So my probability is favorable events over total events. So there are 3 outcomes where I get what I'm looking for. And then out of how many total? Well, this is just a 6 by 6 table. So it's out of 36 total, because 6 times 6 is 36. Of course, you have to simplify. If you forget to simplify, you're going to lose some points, and that's a silly thing to do. So divide top and bottom by the same number. 3 divided by 3 is 1. 36 divided by 3 is 12. So our probability of landing on a 4 and then rolling a number greater than 3 is 1 out of 12. Okay? So if we look, we can also answer a slightly different kind of question with this dice chart. And you'll see this one very frequently on the OAA. What is the theoretical probability of rolling 2 dice, that's 2 separate events, and getting a sum greater than 9? Sum, I want to remind you, is addition. So remember back when we were doing the table and I told you that you needed to leave plenty of room? Well, here's why. Hang on. There we go. When we're solving a problem that asks for the sum, well, we have to find the sum of these different numbers. So if I roll a 1 and a 1, that's going to be 1 plus 1, which gives me 2. See why I made you guys leave some room? So here I'm filling out the dice chart based on the sum of the 2 numbers, not necessarily what 2 numbers are showing. Does that make sense? Filling in actually the sums is it's quite a bit easier than listing the first and second die, and I'm going to show you that. Of course, my eraser is really awesome. Now you only have one dice chart on your paper, so you're just going to have to fill it in there as well. But there's some really nice patterns that happen. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So this is just counting up. 2 plus 1 is 3, and that's going to count up. 6, 7, 8. And so you can see a pattern starting to form that makes actually making this dice chart a lot easier. So you, on the OAA, I expect, that in your work, you'll have several of these dice charts drawn because I know that there's going to be questions like this. If you remember, the problem we're looking at says, what's the probability of getting a sum greater than 9? If we go back here, I want to look for the numbers that are greater than 9. So I've got 12, 11, 10. And I'm not going to highlight 9 because 9 isn't greater than 9. Now I have to count them up. So I have 1, 2, 3, 4, 5, 6 numbers that are greater than 9. And it's out of 36 total. So 6 out of 36. We can divide the top and the bottom by 6. And I get 1 out of 6 for the probability of rolling a sum greater than 9. Hopefully this is making a little bit of sense. We'll do tons of practice tomorrow. Give this, oh golly, I'm running out of time. I'm going to do this really quick. Remember the reflection from last night where you had a spinner that you spun and then a coin that you flipped? You could use a table to do that as well. I'm going to put the colors of the spinner on top. We have blue, green, purple, yellow, red, orange, and then I have heads or tails on the coin. So inside these boxes, inside the table, I'm going to be filling in the different possible outcomes. This is going to remind you of the organized list that we ended up making yesterday. And then I'm looking for the number of ways that I land on blue and then land on heads. There's only one, which gives us 1 over 12, just like we did when we worked through that reflection this morning. So in some cases, making a table is easier than making a tree diagram. But remember, it can only be done when you have exactly 2 events. So landing on blue, flipping a coin, rolling a 3, then rolling a 5. For your reflection, I want you to create a table and use it to find the probability of rolling a die and landing on 4, then spinning a spinner with 3 sections, okay, blue, green, and yellow, and landing on either blue or green. Okay, so we have a die, and we have a spinner. Type your answers into Edmodo, and I look forward to seeing what you come up with. Bye-bye. Bye-bye.